dimension T. For gull wings, the fillet height may extend to the top bend of the lead or knee, but should not touch the component body or end seal as a maximum fillet height. As an exception to this rule, solder may touch the body of plastic SOIC or SOT components.
Dimension F is determined by lead thickness or dimension T. When T is equal to or less than 0.38 millimeters, the minimum heel fillet height is 100% of dimension T. When T is greater than 0.38 millimeters, the minimum heel fillet is 50% of T.
Our final parameter is end overlap, or dimension J, which refers only to chip components.
The amount of overlap between the component termination and the land must be a minimum of 50% of dimension R, which is the length of the component termination.
Now that you've been introduced to the concept of acceptance requirements, product classes, and soldering terminology, let's examine the dimensional criteria for Class 3 surface mount solder joints. We'll start by reviewing the target condition, or the ideal surface mount solder joint for rectangular chip components, J-lead components, and gull wing components. Notice how the solder feathers smoothly onto the land and up onto the lead. The solder fillet is curved inward or concave. The solder covers all of the land and the lead. The texture is smooth and shiny. The outline of the lead is visible beneath the solder. The amount of solder here is just about perfect. The following examples show the limits of component misalignment and solder joint size for chip, J-lead, and gull wing components. Solder joints that do not meet any of these minimum conditions are considered defects. In these examples, the termination or lead will be identified as dimension W, and the land identified as dimension P. The first parameter we'll look at is side overhang, or dimension A. Chip components may overhang the side of the land a maximum of 1/4 of the width of the component termination, or 25% of the width of the land, whichever is less. For example, if the width of the component termination is less than the width of the land, then we'll have to use 1/4 the width of the termination as our maximum guide.
J-leads and gull wings can also overhang the side of the land a maximum of 1/4 the width of the lead, or 0.5 millimeters, whichever is less for gull wings.
The next parameter we'll examine is end overhang, or dimension B. This dimension is called toe overhang for J-lead and gull wing components. For chip components, any part of the termination extending beyond the land is unacceptable. That's because you want the maximum connection with the land. This dimension is not specified for J-lead connections. As long as the solder joint meets all of the other dimensional criteria, this condition would be acceptable. Any extension of the tip of a gull wing lead must not violate the minimum electrical clearance between any adjacent component lead or exposed circuit trace. Now let's look at end joint width, or dimension C. The width of a chip component solder joint at its narrowest point must be at least 3/4 of the width of the component termination, or 75% of the width of the land, whichever is less. The width of a J-lead or gull wing solder joint at its narrowest point also needs to be at least 75% of the lead width. Side joint length, or dimension D, only relates to J-lead and gull wing components. The side joint length of the J-lead solder joint at its narrowest point should be a minimum of 1 1/2 times the width of the lead. Let's look at gull wing side joint length. If there is a long foot length, meaning that L is equal to or greater than 3 lead widths, the side joint length should be a minimum of 3 widths, or 75% of the foot length, whichever is longer. If there is a short foot length, meaning that L is less than 3 lead widths, the minimum side joint length is 100% of the foot length. Our next parameter is fillet height, which is specified by dimensions E and F. These dimensions are called heel fillet height for J-lead and gull wing components. For chip components, the solder may overhang the land and extend onto the top of the termination, but should never touch the component body. For dimension F, the minimum fillet height should extend at least 25% of the height of the component termination, or 0.5 millimeters, whichever is less. For J-leads, the solder should never extend up high enough to touch the body of the component. For dimension F, the minimum heel fillet height should be at least as high as the component lead thickness. For gull wings, the fillet height may extend to the top bend of the lead, or knee, but should not touch the component body or end seal as a maximum fillet height. As an exception to this rule, solder may touch the body of plastic SOIC or SOT components. For dimension F, the minimum heel fillet height should be at least as high as 100% of the component lead thickness at the toe. Our final parameter is end overlap, or dimension J, and refers only to chip components.
The amount of overlap between the component termination and the land must be a minimum of 75% of dimension R, which is the length of the component termination.
This final section describes the most common solder joint defects and process indicators for chip, J-lead, and gull wing components used in Class 2 and 3 products. Before we start, let's discuss process indicators. Sometimes a solder joint will meet the minimum acceptance criteria, although it may exhibit certain cosmetic imperfections that are not detrimental to the reliability of the solder joint. These types of conditions fall into a category called process indicators. The idea here is that the process that created these cosmetic imperfections should be changed, rather than the cosmetic imperfection. This makes a lot of sense, because when you fix the process, the incidence of imperfections will be reduced or eliminated. Now let's examine the defect criteria for surface mount solder joints. This is what insufficient solder looks like for our 3 components. You can see that the solder fails to meet minimum fillet heights from our dimensional criteria, and there is no evidence of a properly wetted fillet. When the solder extends onto the body of a surface mount component, this is considered excessive solder. Excessive solder is a defect for either class of component. As an exception to this rule, solder may touch the body of plastic SOIC or SOT components. Now let's look at non-wetting. Notice that the solder has not adhered to either the termination or the land. Non-wetting is a defect for all types of surface mount connections. De-wetting occurs when molten solder coats the surface, then pulls back, leaving only a thin film of solder covering the land in some areas and irregular mounds of solder in others. A disturbed solder joint is characterized by a gray, porous appearance with stress lines from movement of the solder while solidifying. This is what a fractured or cracked solder joint looks like on our 3 types of components. A cracked solder joint will not allow the electronic signal to flow. That's why this condition is a defect. Tombstoning is a defect that's specific to chip components. Notice how one end of the component termination is completely lifted off the land. Tombstoning also interrupts the electronic signal and needs to be fixed. On the other hand, coplanarity is specific to J-leads and gull wings. This defect occurs when one lead, or a series of leads, is out of alignment and fails to make contact with the land. If there is no electrical contact, this condition will need to be repaired or reworked. A void is an open area caused by air trapped within the solder joint. This is an allowable condition as long as solder joint dimensional requirements are met. Voids are an example of a process indicator. Pinholes and blowholes are also process indicators. Blowholes are larger than pinholes and are created when heated gas escapes from inside the solder joint. Solder webbing is a defect that occurs when a film or splash of solder covers any area of the assembly that should be free of solder. Solder bridging is a connection of solder across conductors that should not be electrically joined together. Bridging is always a defect since it misdirects the electronic signal. Incomplete reflow occurs when insufficient heat is applied to the assembly during the soldering operation. This means the solder paste may not have properly wetted the surfaces to be soldered and will not form an acceptable electrical and mechanical connection. Any balls of solder that are not entrapped within a permanent coating or attached to a metal contact or violate minimum electrical clearance requirements are also considered defective. Any adhesive material in the termination area is considered a process indicator for Class 2 and a defect for Class 3. Adhesive causing less than minimum end joint width is considered a defect for both classes. Solder fines are small balls of solder paste that have splattered around the connection during the solder reflow process. This condition is considered a defect when the solder is not encapsulated or attached to a metal surface, or the solder fines violate minimum electrical clearance. Any significant cracks or stress fractures in the component body are also considered a defect, as well as any nick or chip out that exposes the electrodes or resistive elements. Again, that's because the electronic signal will be interrupted. This program has explained the workmanship standards for evaluating critical acceptance criteria for the most common surface mount solder joints. Solder joint evaluation is a very important job in electronics assembly. When the criteria are not properly understood, the results are unnecessary touch-up and rework, and unreliable products. Your careful attention can make a big difference in the production of high-quality electronic assemblies.